Everyone, I'm Ajay and welcome back to the channel. This is the second part of the summarization of Python course. If you didn't watch the first part, the link is in the description as well as it's added to the InfyTQ playlist. You can just go through that. And this video is made from the reference of InfyTQ website and W3 School website. So for more clear content and for more information, just visit this website. And this complete PDF and as well as the handwritten notes of Python and all the required links are mentioned in the description. Please go through that. So let's start with this video. Okay, so that was about introduction, and first thing is variables and scope. I already discussed about variables in the previous video, that is the part 1. Variables, nothing but name given to a value. Name given to a value. Those are called the variables, and there are many different definitions for variable. So this is the basic difference, definition. So after that we have scope. Generally in scope we have two types. One is local scope and second one is global scope. Okay, so local scope, that is the local variables, are the ones which are created inside a function, and they are created when the owning function starts execution and remains in memory till owning function finishes execution. If I say in a clear words, it's like it's created in a function, so its lifespan starts at the time of creation in the function, and when the control comes out of the function, the local scope just over. The local scope of the variable gets over. That's about local scope. While in the global scope, that's the global variables. Global variables are the ones which are created outside the functions, and they are created when the program execution starts and remains in memory till the program terminates. So these are the variables that are created outside the function, and this for the local variable we said that it starts at the time of creation. When the control exits from the function, the lifespan of local variable gets completed. Whereas for the global variable, it just stays in the memory until unless the complete code execution is done. Also, we have a keyword global, through which you can define like global n equal to 10 inside some function like def function. Then as we used a global, this complete n is being declared in a global way. So even in the inside function, when we use global keyword, we can make a variable as we can make a local variable as a global variable. That's about scope. Next we have unit testing in Python. Let's take a new page. Okay, unit testing. Yeah, so we generally write programs, so we write many algorithms, logic for everything, but we were not sure like whether the program is correct or not. So one way of evaluating that is through code review. We can just it's like a peer-to-peer review, so anyone can sit through that and manually review the code line by line. That's one solution, but as it's done manually, so there are some cases where it may be missed out and many issues can rise. So for that, the best solution is testing. So in the testing, it's like we need to first the testing performs like some series of statements. Like first we need to identify the values for the input. Identify. Okay, yeah, identify values for the input. So we need to first identify the input, then run the program with the inputs collected in first one, and the third point is check whether the check whether output is matching as required. As requirements, as it's following the logic or not. Fourth, if there is a match, that is if it's matching, then it means code is working fine. If it's not matching, something went wrong. This is a 5 step the majorly testing takes place, and when the testing repeat these statements in a cycle to again and again to find the issues if there are any issues or that are present in the code or not. And for the unit testing, as for the InfyTQ, there are majorly two types of categories are there. One is path or logic coverage. Second one is boundary values. Yeah, in the path or logic coverage, if you take example like age is equal to 10, age 10, age 8, age 9, age 5, age 10. So let's suppose this is a condition and it has like true and false, true and one false. Such way it executes. So you can see the logic is that logic testing happens so that it mainly check the logic. Like if you pass 10, is checking whether it's 8, no, whether it's 9, no, whether it's 10, yes. So in this, the true statement execute and whatever statement is written below will get executed. That's about logic testing. It's mainly to check the logic. But here we have missed something. Here we are just checking a single value or checking a single value. But there might be cases where some single values or some range of values where it exceeds the limit from the code, or it decreases the minimum limit from the code. So to test such, there are called boundary values, and it's mainly checked in 3 phases. One is like on boundary, that is on the boundary to inside the boundary, and next is upon the boundary to check the values exceeding the boundary, and third one is less than boundary. This way, and instead of checking a single single type of input in boundary values testing, we usually follow like whether it's less than or equal to 8 and greater than or equal to 9 or not, whether it's less than or equal to 10 and greater than or equal to 11 or not. So we usually follow a range so that we can have more and more form of testing. And that's about unit testing and 2 types of unit testing, and is one of the subcategories path or logic coverage, and another is boundary values. So these are the 2 things that are as per the InfyTQ syllabus. Now come to the next topic, exception handling. Okay, let's create one more page. Yeah, exceptional handling. So those of who don't know about exception is like any kind of an error where it can be a runtime error, or it can rise at the compile time as well, where it happens is that because of any certain logic or any scenarios, there is a chance that any error or situation rise where the program will completely get stopped. That's it's called exception, and we do exception handling so that when there is a situation where such issues rise, so that we can handle that exceptions and do the necessary steps so that the code runs continuously even when there is an exception occurred. If you don't do exception handling, even if there is a one scenario where an issue rises, the complete code will get stopped at there. So to avoid that, we do exception handling. And we have various built-in exceptions like zero division error, and next one is type error, and one more is name error, index error, value error. Zero division error, when a value is divided by 0, then this is raised. And for the type error, when we try to do an operation with incompatible data types, like if we take an example like a string is equal to, not string, let's take a number n equal to 5, and in the next line we write like n plus or equal to a string like Ajay. So we are trying to concatenate a string to an integer. That's because of that there is a exception, that is a type error. And name error, like when we try to access a value which is not defined. So suppose we have something like num is equal to n divided by 5. See we have num, that is we are declaring here, and we are just assigning that, but previously we didn't declare the n value, so n value is not declared, so because of that name error might be raised. And in the index error, when we try to access an index value which is out of range, suppose we have a list 1 2 3 4, so this is a 4 length list. So suppose I just access L of 6 which is not present, and it's exceeding the index, that is exceeding the length, then it will raise an index error. And the last one, value error, when we use a valid data type for an argument of a built-in function but passes an invalid value for it. Let's suppose there is a string capital A, and n equal to int of s. So int of capital A, that's a value error, because we want to convert a string to an integer, but the string contains only an alphabet, so because of that the value error is raised. And to handle exception handling, we majorly use keywords like try and except in Python. In try, we write the doubtful code, all the doubtful code, and after except we write what exception can be raised, whether it's a zero division or whether it's a type error, whatever exception you write, we just write, and after colon, if the exception is what exactly need to be done, then we write here. And if you want some code that it should be executed even there is an exception or not, then we use finally. Now there is a syntax like for each exception we raise except zero division error. If this exception is not satisfied, then it will go to the below one, to the type error. That way we need to handle. But we want to handle all kind of exception, then we just need to leave just like this except. Then because of that it will accept any kind of exceptions, and whatever statements you will give, it will get executed. That's about exception handling. Coming to the next concept, recursion. Okay, a new page. Recursion in Python. Okay, so we know about functions. Functions is a block of code, and it may have return statement or not. So when a function call itself, that condition is called as recursion. See, suppose you have something like a function some n value, we kept like if n is less than 1, return 0, otherwise return function of n minus 1. So because of that, first function 1, that is function, suppose we have 10 here, function 10 will get executed. Then if it's not satisfied, function 9, function 8, function 7, function 6, and so on till the return statement, that is 0. So the function calling itself is known as recursion. And recursions are very useful, and for the recursion mainly first is the recursive logic, that is here, this one, that is calling a function itself, and next most importantly a base condition at which point the recursion should break, because if we don't mention the break condition, the function will recursively call itself and itself again, and at last it will result in a stack overflow error. Yes. So if we take the basic example about how recursion plays an important role. Let's say example of Fibonacci series. In Fibonacci series, if we um, we declare two variables like a equal to 0 and b equal to 1. Then we keep like for I in the range of 2 comma n plus 1, and we use another variable c equal to a plus b, a equal to b, b equal to c, and we just stored all the c values and everything, and we just return it. That's about a basic function of Fibonacci. But what if we use recursion in Fibonacci? Recursion in Fibonacci series, that is Fibonacci code. If you use recursion in Fibonacci code, then it will be like the function. We will just accept the number, and the base condition will be if n is less than or equal to 1. In such case, we just need to return n, that is if 0, or it will return 0, if it's 1 it will return 1. Otherwise we just need to return function of n minus 1 plus function of n minus 2. You can see, because we are using a recursion, the complete Fibonacci series just derived and can be built in smaller steps. So that's how the recursion plays an important role. It gives a lot of advantage of building a heavy logics, which requires a lot of loops and in a normal programming. So that's about recursion. And the next topic, file handling. Okay. File handling. Yeah. So file handling is very important, because if you have any file, local files or anywhere, and if you want to do read operation, write operation on any kind of files, then it's important to know how exactly the file handling takes place in Python. So in Python, we have method open. The syntax is first is open, then the file path, and next is operation. Operation can be read, write, or append. And it's like R for read, W for write, A for append. And to close a file, we have method as close. To write a file, we have method as write. To read a file, we have method as read. So suppose we open a file in a read mode, like f equal to open of file name .txt in a read mode, and we copy the complete data into another variable text. Okay. Yeah. So we copy the one complete data into a variable text. It's like f dot read. So using the read, we are copying the complete data into a variable text, and we can just print text, so all the data inside the file can be printed out. And if you want to write, we just write like f dot write of the string we require, but as we used in our read mode, we cannot write it in this code. If we try to write, then there might be an exception or error rise. To handle that, we always need to maintain exception handling in file. We should stay to close the file whenever it's open, because if any exception dies, the code stops and the open file will not get closed. So it's better practice to close the file in all the exception cases. That's about file handling and all the methods. So as and when required, we can use such methods. And lastly, we have is modules and packages. Okay, let's write it down here itself. Modules. Modules is nothing but a variable. It can be a variable, it can be a set of functions that residing in a file. A single file is termed as modules. First thing is to if you take an example, like you just create a function, def function, and just keep something like name, and in return or in print you can just keep welcome name. So and save this in some welcome.py. So this function is saved in welcome.py. So this becomes a module, and if you want to use this module in another file, suppose we have this like main.py, in this we need to import that module. So import welcome, that instead of .py we just keep welcome with removing the .py, and here we just call welcome not a function that is fun of name, like Ajay, and the name will be printed, that is welcome Ajay. That's how the module works. So module is a single file which contains a function or variable. It can contain anything. But coming to packages like group of modules. That's it. And we have built-in functions. Suppose if we take the math package or math module, you can see we generally use mathematical operations like min, max, power, which takes power like n and exponential power. And if you want to use square root or find a seal value, find a floor value, or you want a pi value, all such things are present in math model. You just need to import the math module, import math. After that, math.seal to get the seal value, math.floor to get the floor value, and math.py. We have a lot of things like that. So there are a lot of methods in math module. So even such, it's just example that this is one module. So there are many other models present in Python. So that's about modules and packages. So then we are done with the complete course of Python here. The course link for the part 2 is mentioned here. You can just go through that. You can just click on it and go through that, or you can just go to the InfyTQ website manually and complete the complete course. That's about this video, and all the very best to everyone. Thank you.